Deep in the Siberian wilderness, the Earth is literally tearing itself open, and what's climbing out has been frozen for millennia. This isn't just a geological collapse, it's a gateway to a lost ecosystem. We're witnessing the awakening of ancient pathogens and prehistoric forests that should have stayed buried forever. In the remote wilderness of northeastern Siberia, a colossal wound has been tearing itself wider with each passing year. Known as the Batagaika Crater, or more ominously, the gateway to the underworld. This massive scar in the Earth is no longer a slow-moving geological curiosity. It has become a rapidly expanding abyss, driven by unprecedented heat. By 2026, record-breaking temperatures have accelerated its growth to alarming levels, causing the crater to nearly triple in size within a shockingly short span of time. From above, the crater resembles a monstrous jaw forced open, its edges jagged and unstable. What was once a modest depression decades ago has transformed into a sprawling megaslump stretching over a kilometer in length. Entire sections of land collapse without warning as the permafrost, once solid and permanent, melts into mud and gives way. The process is relentless. Each summer brings longer thaw seasons, deeper collapses, and faster expansion. The Earth here is not simply eroding, it is unraveling. At the heart of this transformation lies permafrost, ground that has remained frozen for tens of thousands of years. But as temperatures surge beyond historical norms, this ancient ice-bound soil begins to thaw. When it does, it loses structural integrity, triggering landslides that feed the ever-growing moor. Scientists have described it as a self-reinforcing cycle. The more it collapses, the more surface area is exposed, accelerating further thaw and collapse. In 2026, this feedback loop reached a terrifying intensity, yet the visual destruction is only part of the story. Those who have ventured near the crater report something far more unsettling, an eerie acoustic phenomenon known as the booming of the underworld. Deep, resonant sounds echo from within the crater, like distant thunder trapped beneath the ground. These noises are not constant. They emerge suddenly, unpredictably, sending vibrations through the air. The source of these sounds is as violent as it is fascinating. As massive chunks of thawing permafrost collapse inward, they trigger seismic-like reverberations. Layers of ice and soil, some dating back hundreds of thousands of years, fracture and fall into the depths. The resulting impacts produce low-frequency booms that travel across the barren Siberian landscape. To witnesses, it feels less like geology and more like the Earth itself is groaning under stress. But perhaps the most extraordinary aspect of the Batagaika Crater is not its size or its sound, it is what it reveals. Each collapsing wall exposes layers of sediment frozen in time, offering a direct window into the Middle Pleistocene era. Fossilized remains, ancient pollen, and even preserved carcasses of long-extinct animals have been uncovered within its depths. This is not just a hole in the ground, it is a living archive of Earth's distant past. Scientists now consider the crater one of the most accessible natural records of prehistoric climate and ecosystems. Unlike traditional excavation sites, where digging is required, Batagaika unveils its secrets through destruction. Every collapse reveals new layers, some over 200,000 years old. It is as if time itself is being peeled back, one landslide at a time. And yet, this portal into the past comes with a stark warning about the future. The same forces exposing ancient history are also releasing vast amounts of greenhouse gases trapped within the permafrost, carbon dioxide and methane that have been locked away for millennia. As they escape into the atmosphere, they contribute to further warming, intensifying the cycle that created the crater in the first place. The Moor of Siberia is not just a geological anomaly, it is a symbol of accelerating change, a place where the boundaries between past, present, and future collapse alongside the land itself. Standing at its edge, one does not simply look into a crater, one looks into deep time, into a warming world, and into a process that, once unleashed, may be impossible to stop. As the walls of the Batagaika Crater continue to collapse and retreat, they are doing more than exposing layers of frozen soil. They are resurrecting an entire prehistoric ecosystem long believed lost to time. Embedded within the thawing permafrost are perfectly preserved root systems, ancient tree stumps, and organic structures that have remained untouched for over 200,000 years. These remnants are not fossilized in the traditional sense. Many retain their original cellular integrity as if they had only recently been buried. The roots emerge in intricate networks, still intertwined with the soil that once nourished them. Some extend meters across the exposed cliff faces, revealing the scale of vegetation that once thrived in what is now a harsh, frozen landscape. Tree stumps, darkened but intact, stand frozen in place, silent witnesses to a time when this region supported forests rather than tundra. The preservation is so precise that even microscopic structures within the plant tissues can be analyzed, offering unprecedented insight into ancient Arctic flora. These discoveries have led scientists to a startling conclusion. Siberia, during parts of the Middle Pleistocene, was significantly warmer than previously believed. The presence of what researchers now call ghost forests suggests that dense vegetation once covered areas that are today barren and inhospitable. Traditional climate models had underestimated the extent of this warmth, but the evidence embedded in Batagaika's walls tells a different story, one of a dynamic and fluctuating Arctic climate capable of sustaining complex ecosystems. The implications are profound. If forests once thrived this far north, it means the Earth's climate system has experienced dramatic shifts long before human influence. However, the speed at which similar changes are now occurring raises concerns. The past unfolded over thousands of years. The present is accelerating within decades. Perhaps even more extraordinary is what happens when these ancient biological materials meet the modern world. Seeds, spores, and organic compounds that have been locked away in darkness for millennia are suddenly exposed to sunlight, oxygen, and fluctuating temperatures. For the first time in hundreds of thousands of years, they are interacting with an environment that is both familiar and entirely alien. Some of these ancient seeds show signs of biochemical activity upon thawing. While not all are viable, certain specimens have demonstrated the ability to rehydrate and initiate early stages of germination under controlled conditions. It is as if fragments of a lost world are attempting to awaken. Scientists approach these findings with both excitement and caution, recognizing the potential to better understand plant evolution, resilience, and adaptation. At the microbial level, the story becomes even more complex. Dormant microorganisms, bacteria and fungi preserved within the permafrost, are also reactivating. Their responses to modern atmospheric conditions could reshape local ecosystems in unpredictable ways. These organisms evolved in a different climate regime, and their reintroduction into today's biosphere raises questions about ecological balance and potential risks. The crater, therefore, is not just revealing a prehistoric wilderness, it is, in a sense, reanimating it. Each newly exposed layer blurs the boundary between extinction and persistence, between what is gone and what might return. The ghost forests are no longer just remnants, they are active participants in a rapidly changing environment. In this unfolding process, Batagaika becomes something even more extraordinary than a geological phenomenon. It is a threshold, a place where ancient life meets modern conditions, where the past is not merely observed but begins in subtle ways to interact with the present. And as this interaction deepens, it forces us to confront an unsettling question. Are we simply uncovering history, or are we inadvertently bringing it back to life? As the Batagaika Crater continues to carve deeper into Siberia's ancient permafrost, it is not only uncovering forests and ecosystems, it is revealing the long-buried giants of the Ice Age. From within the frozen layers, remarkably preserved carcasses have begun to emerge, offering an unprecedented glimpse into a world dominated by megafauna. Among the most striking discoveries are steppe bison and juvenile woolly mammoths, their bodies so well preserved that soft tissue, fur, and even traces of blood and DNA remain intact. Unlike typical fossils, which are often reduced to bone, these specimens are time capsules. Muscles, skin, and internal organs have survived in a state of near suspension, protected by the deep freeze of permafrost over tens of thousands of years. In some cases, the animals appear almost lifelike, as though they had only recently fallen asleep beneath the ice. This level of preservation allows scientists to conduct detailed biological analyses, sequencing DNA, studying cellular structures, and even reconstructing aspects of their physiology with extraordinary accuracy. These discoveries are beginning to challenge long-standing assumptions about extinction timelines. Traditionally, it was believed that many Ice Age megafauna disappeared rapidly around the end of the last glacial period. However, new evidence from these frozen pockets suggests a more complex story. Some species may have survived far longer than previously thought, persisting in isolated microclimates where conditions remained stable enough to sustain them. These hidden refuges, Protected valleys, shaded basins, and cold air traps could have acted as sanctuaries, delaying extinction by thousands of years. The Batagaika region, with its unique geological and climatic conditions, appears to have been one such refuge. The presence of relatively recent remains compared to established extinction dates forces scientists to reconsider how and when these animals truly vanished. Even more transformative is the role of advanced 2026 carbon dating technologies in decoding these mysteries. With unprecedented precision, researchers can now construct highly detailed chronological maps of when these animals lived, migrated, and died. By analyzing isotopic signatures within bones and tissues, scientists can determine not only age but also diet, seasonal behavior, and environmental conditions at the time of death. These methods have revealed patterns of sudden environmental stress, rapid temperature shifts, changes in vegetation, and disruptions in water sources. In many cases, the data suggests that these animals did not gradually fade into extinction, but were instead caught in abrupt and extreme climate events. The frozen carcasses, therefore, are not just remnants of a lost world, they are records of ecological collapse. Perhaps the most unsettling aspect of these findings is their relevance to the present. The same forces that once drove rapid climate shifts in the past appear to be accelerating again, this time at a pace influenced by human activity. The sudden reappearance of these megafauna, emerging from thawing ground, serves as both a scientific breakthrough and a warning. Each carcass uncovered is a message from a vanished ecosystem, preserved in ice and now released into a warming world. They tell a story of resilience, adaptation, and ultimately, vulnerability. And as more of these ancient giants rise from the permafrost, the question becomes impossible to ignore. Are we witnessing the final echoes of extinction or the first signs of a cycle beginning anew? As the Batagaika Crater continues to unveil its frozen archives, the focus of discovery is shifting from the visible to the invisible, from massive bones and preserved carcasses to something far more unsettling. Beneath the layers of ice and soil, locked away for tens of thousands of years, lie microscopic entities that once thrived in prehistoric ecosystems. Now, as the permafrost thaws, these ancient viruses and bacteria, often referred to as zombie pathogens, are beginning to reawaken. Shielded from radiation, oxygen, and decomposition by the deep freeze, some of these pathogens have retained their structural integrity. In laboratory environments, scientists have already demonstrated that certain ancient microbes can become viable again when thawed. In laboratory environments, scientists have already demonstrated that certain ancient microbes can become viable again when thawed. This raises a critical and unsettling possibility. The past is not entirely dead. It may still be biologically active. Among the most concerning discoveries are strains of prehistoric influenza and anthrax-like bacteria extracted from permafrost layers estimated to be over 50,000 years old. These are not identical to modern variants. They belong to evolutionary branches that diverged long before recorded history. Their genetic makeup presents both a scientific opportunity and a potential risk, as modern immune systems have never encountered anything quite like them. To address this threat, research teams in 2026 are operating under some of the strictest containment protocols ever implemented. Samples retrieved from thawing sites are immediately transferred to high-security laboratories equipped with advanced biocontainment systems. These facilities, often classified at the highest biosafety levels, are designed to prevent any accidental release. Researchers work in sealed environments, wearing fully pressurized suits, while robotic systems handle the most sensitive procedures. Every stage of analysis is tightly controlled. Before any attempt is made to revive or study a microorganism, its genetic sequence is mapped in detail. This allows scientists to assess potential risks, identify similarities to known pathogens, and determine whether it poses a threat to humans, animals, or plants. In many cases, fragments of genetic material are studied without attempting full reactivation, minimizing the danger while still extracting valuable data. Yet even with these precautions, uncertainty remains. The greatest concern is not necessarily what is already known, but what remains undiscovered. Permafrost has acted as a vast biological vault, preserving organisms from countless eras, many of which have never been studied or even identified. As thawing accelerates, the The rate at which these materials are exposed is increasing, potentially outpacing our ability to safely analyze them. The implications for modern ecosystems are profound. Today's flora and fauna have evolved in the absence of these ancient pathogens, meaning they may lack any natural immunity. A virus or bacterium that once circulated in prehistoric environments could behave unpredictably in contemporary systems, potentially infecting new hosts or disrupting ecological balances. Even a localized outbreak could have cascading effects, particularly in fragile Arctic regions already under environmental stress. There is also a broader, more complex dimension to consider. These microorganisms are part of Earth's evolutionary history, carrying genetic information that could reshape our understanding of disease, adaptation, and survival. Some may even hold clues to medical breakthroughs, offering insights into viral mechanisms or resistance strategies. But this potential comes with a paradox. The same qualities that make them scientifically valuable also make them potentially dangerous. The rise of ancient pathogens transforms the narrative of Batagaika from one of discovery to one of confrontation. It is no longer just about uncovering the past, it is about managing its return. Each thawing layer presents a choice between knowledge and risk, between exploration and containment. In this emerging reality, the crater becomes more than a geological or archaeological site. It becomes a biological frontier, where the boundaries between extinction and persistence blur at the microscopic level. And as humanity pushes deeper into this frozen archive, one question grows ever more urgent. Are we prepared not just to uncover the past, but to face what it might still carry within it? What began as a window into the distant past is now revealing something far more immediate, a projection of what lies ahead. The Batagaika Crater, once studied as a geological anomaly, has evolved into a living model of climate transformation. As its walls collapse and retreat, they expose vast reserves of organic material that have remained frozen and undecayed for tens of thousands of years. Now, for the first time in millennia, this material is being reintroduced to warmth, oxygen, and microbial activity, and the consequences are immense. At the center of this transformation is methane, a greenhouse gas far more potent than carbon dioxide in the short term. Locked within the permafrost are immense quantities of ancient plant and animal matter that never fully decompose due to the cold. As thawing accelerates, microbes begin breaking down this material, releasing methane into the atmosphere in significant bursts. In some areas, the emissions are not gradual but sudden, erupting from the ground in concentrated plumes as trapped gas escapes. This process creates a dangerous feedback loop. Rising temperatures trigger permafrost thaw. Thaw releases methane. Methane intensifies warming, and warming accelerates further thaw. The Batagaika Crater exemplifies this cycle in its most extreme form. It is not just reacting to climate change, it is actively amplifying it. Scientists are increasingly viewing the crater as a predictive model for the broader circumpolar north. What is happening here in concentrated form may soon unfold across vast regions of Arctic and subarctic terrain. By 2030, large portions of permafrost-rich landscapes could begin to exhibit similar patterns. Ground collapse, methane release, ecosystem disruption, and irreversible land transformation. The phrase "gateway to hell," once used as a dramatic nickname, is taking on a more literal and scientific meaning. It reflects not only the visual appearance of the crater, but also its function as an entry point into a destabilized climate system. The ground itself becomes unreliable, infrastructure collapses, and landscapes once considered permanent begin to shift and erode at unprecedented rates. Entire ecosystems are already feeling the effects. As the land subsides and reshapes, water systems are disrupted, lakes drain or suddenly form, rivers change course, and vegetation struggles to adapt to unstable soil conditions. Species that depend on consistent environments are forced to migrate, adapt, or disappear. What emerges in their place is not a restoration of ancient ecosystems, but something entirely new and uncertain. This is where the connection between past and future becomes unavoidable. The crater reveals a prehistoric world, its forests, its megafauna, its microbial life, but it does so through a process that is simultaneously dismantling the present. The same thaw that exposes ancient roots also destroys modern terrain. The same warming that resurrects long-lost organisms also creates conditions that may be inhospitable for current life. In this sense, Batagaika is both archive and warning. It shows us what Earth once was, while demonstrating how quickly it can change. The ancient world emerging from its depths is not returning to reclaim the present. Instead, it is being revealed as the present transforms into something else. What makes this realization so powerful is its immediacy. This is not a distant projection or a theoretical model. It is happening now, in real time, visible from satellites and measurable in the air itself. The future is not approaching slowly. In places like Batagaika, it is already unfolding. Standing at the edge of this vast and expanding chasm, one is confronted with a profound truth. The boundary between past and future is far thinner than we imagined. As the Earth releases what it has held for millennia, it is also rewriting what comes next. And in that unfolding story, the maw of Siberia is no longer just a scar. It is a mirror, reflecting a future that is rapidly becoming unavoidable. If this story makes you think, I'd love to hear your perspective. Do you believe places like Batagaika are simply natural phenomena, or are they warnings we're not taking seriously enough? Drop your thoughts in the comments below. And if you enjoy deep, mind-expanding content about science, history, and the mysteries of our planet, make sure to subscribe and turn on notifications so you don't miss what's coming next.